then raise your hand if you think you know how to do D. Ooh, that's a little on the disappointing side. Holy cow. Okay, this is clearly an isosceles triangle on A, so the base angles are congruent, so we set the two of those equal, divide both sides by 3, we get 10, no problem there. This is base angles are congruent, that makes this an isosceles triangle, so the two sides would have to be equal to each other, so I just move the 4 over by subtracting 4x, move the 10 over by adding 10, so you get 3 equals x, or x equals 3. Here we've got to start with this exterior angle, and know that this one would have to be supplementary, so that's going to be 58. Those are congruent, so that's got to be 58. I added those together, got 116. That means what's left over for this vertex angle is 64. It's vertical with this one over here, so that's 64. Those are both base angles of an isosceles triangle, so that's got to be 64. And then that's got to be supplementary with this exterior angle, so that's going to be 116. Any questions there? Okay, let's take a look at this one right here. We want to find the equation of the line that goes through -2, 1 and has a slope of 3/4. Did this a whole bunch in 8th grade math. That would have been in 7th grade. You did some more of it last year. Here's a quick little reminder. A lot of the times people really like slope-intercept form, so that would be y equals mx plus b. They gave us the slope. So at the very least, if you saw something like this on an ACT test or anywhere, you could at least do this. Y equals 3/4 x plus b, and say, hey, I've got half of it. I just don't know how to find the other half. But remember, there's something that a lot of people forget. If that's an equation, and that point is on that equation, if it's on that graph, it should work in the equation, and we've got an x and y there. So I'm going to take this x and that y, and I'm going to plug it in. I've got an equation with 3 variables. Can't solve an equation with 3 variables, but I can solve it if I've got 1. So this is going to be 1 equals 3/4 times -2 plus b. Now I can figure out what b is. So I'm going to do a little bit of cross-canceling here. This is going to cancel with that. That's going to be a 2, so that's going to be a negative. So then I'm going to move this over to the other side. So this is going to be a 1 equals, that's going to be a -3/2 plus b. So I'm going to add the 3/2. So I end up with 5/2 equals b. So I get y equals, let's see, I knew what the slope was, 3/4. And then now I know that the y-intercept is 5/2. Good thing I don't have to graph it, because with those fractions it would be kind of a pain. Raise your hand if you got that. All right, nice. Is there another way to do it? That would be a huge pain. Does anybody remember point slope form?
I remembered it.
Okay, you've heard the name, but we're gonna go over that again. So here's the deal of what we're gonna do today. There are times when we're doing some geometry problems, and it's kind of easy to kind of turn off our brains and just forget how and why something works the way it does, and just kind of accept things for fact. Okay, what we're gonna do today is we're going to verify statements. We're gonna verify some geometric statements. And when we prove something, what we do is we prove that it's true for all cases. So we kind of do it in general, okay? With as few numbers as we possibly can, just saying, hey, if this is the case, I can prove that this is the end result no matter what happens. When we verify something, it's slightly different and a little bit easier. What we're going to do is we're just simply going to demonstrate or show that something's true in a particular case. So they're going to give us something and say, hey, can you show that this is true? Can you demonstrate or verify that this particular geometric principle or this theorem that you learned about actually works? Okay? So I'm going to slide down here, and we've got to know these to work with the stuff that we're doing. And we're going to give a name to this by the time we're done with this. But we need a midpoint formula. You should have this memorized. It was on the last test. Somebody want to raise their hand and remind us what the midpoint formula is?
Yes.
That's a yes. Hannah? Very good. We're basically just averaging the two coordinates. Adding the x coordinates together, dividing by 2, adding the two y coordinates, dividing by 2. And then there's some slope formulas that we ought to be aware of. This first one's a little shorter because I'm looking for what we use when we're graphing things. I'm looking for 2 R words. Jack, no hand on this one?
No.
Lizzie? Very good. Rise over run. Then there's another formula that we use when we've got points. Three people Got some x's and y's in it? Got some subscripts? Keely?
Isn't it x2 minus x1 minus 1?
You're really close, except for rise are the y's, so the y's have to go on the top. So it's y2 minus y1 over x2 minus x1, something you're going to want to lock away and never forget. Okay, then the distance formula. We heard that coming up the other day. People were kind of reviewing that. D equals a big square root, and then it's x2 minus x1 quantity squared, y2 minus y1 quantity squared. That's the distance formula. Does anybody remember what we used? There was kind of a geometric principle that we used to derive that. Did it last year? Yeah.
The quadratic formula.
No?
Or not the Pythagorean,
Pythagorean theorem.
Oh,
The
that's
Pythagorean theorem will lead you directly to the distance formula. This is point slope form. So up above we did slope intercept. So I'm going to write y equals mx plus b. That's pretty popular. It's a nice graph friendly form. If you go to some countries, they really don't study slope intercept very much. They focus on point slope form because it's a little bit more adaptable. It's easier to work with. If you take AP, the cool thing is you can leave things in point slope form. You don't always have to change them into slope intercept. So point slope form looks like this. It's y minus y1 equals m x minus x1. Okay, the name says it all. All you need is a point and a slope. You plug them in there. Okay, if you think about it, it's actually an adjustment on this slope formula right here. Okay, parallel lines have slopes that are exactly, what is it?
Same.
Exactly the same. Perpendicular lines have slopes that are opposite. They're not just opposite sign, there's something else that has to happen. One's going up, the other one's going down. Okay, so that takes care of the negative part. Okay, but they kind of have to be in this perpendicular relationship, so what happens?
Is it opposite direction?
Kind of. I'm looking for something else that we do with the fraction. Luke?
Reciprocal?
Reciprocal. They are opposite reciprocals of each other. Okay? So perpendicular lines are opposite reciprocals of each other. Some people do it this way. They say their product is -1. So let me just show you a quick example. If I've got a slope of 1/2, perpendicular to that would be the opposite reciprocal. So that would be a slope of -2. If I multiply those together, if I do 1/2 times -2, I end up with -1. So that's another way to tell whether or not they're perpendicular to each other. Everybody good there? All right. So here's problem number 1. And by the time we're done doing the notes, you will see every type of problem that you're going to see on the assignment. All right? So on this one, it steps you through with some instructions and stuff like that. So it says triangle ABC has vertices A, -4, 1, already labeled, that's nice. B, 8, -1, already labeled, that's nice. And here's C, 2, 9, already labeled. And it says DE is a mid-segment. So that means it connects two midpoints of ABC. It says find the coordinates. So if we're going to find the coordinates of D and E for this point and this point, we got to find midpoints. Yeah.
Do we want to find the distance between C and A first?
Nope, not on this one. Okay? So we're going to find the coordinates of D and E. We're going to find the midpoints. So this is the midpoint of D is in between C and B. So I'm going to put a big capital M here, midpoint of C and B. And this is going to be the midpoint of A and B. So D is going to be, let's see, it's a midpoint. So let's see, it's in between these two guys right here. So we're going to add the x coordinates together. So that's going to be -2 plus 8 divided by 2. And 9 plus -1, or just -1 over 2. So this is going to be, let's see, that would be 6 over 2 and 8 over 2. So I got 3, 4. Is that what you got? Okay.
Yeah.
So over here, we're going to label this as 3, 4, because it's usually nice if you're looking at the diagram, to have all the information on the diagram. So they did us a favor by labeling A, B, and C. So we don't have to look up at the original problem. And then we're going to find E. E is going to be the midpoint between A and B. So that's going to be -4 plus 8 divided by 2. And 1 minus 1 divided by 2. So that's 4 over 2 and 0 over 2. So I got, oops, 2 comma 0? All right, perfect. So that's 2 comma 0. Now comes the verify part. So this is the demonstrate part. Verify that AC is parallel to DE. So if they're parallel, then we're going to need to find some slopes. So I'm going to write it this way. I'm going to write a lowercase AC, and we're going to find the slope between A and C. So that's going to be, let's see, y2 minus y1 over x2 minus x1. So I did other way around. I did y2 minus y1 and x2 minus x1. So that's an 8. That's a plus 4, so that's going to be a 2, so I get a slope of 4. Okay, now, not that you can go by the way things look, because we're verifying things here, but does that go up from left to right, and is it pretty steep? Looks pretty good there. We want to verify that this one has exactly the same slope. So we want to find the slope of DE. So if we're going to find the slope of DE, I'm going to take y2 minus y1, so I'm going to do 4 minus 0. And x2 minus x1, so that'd be 3 minus 2. So I get a 4 on the top, a 1 on the bottom. Are they parallel? Okay. Now, you might occasionally see something like this. You'll see 3 dots in a little triangle. That means that just substitutes for the word therefore. So therefore, AC is parallel to DE. We just verified that. Okay, next, verify DE is exactly half the length of AC. So now we have to check lengths. So I don't remember who said that, but now we're going to have to check lengths. So let's find the length of AC. That would be, let's see, the distance is going to equal a big square root. And from A to C, so I'm going to do 9 minus 1 quantity squared plus -2 minus minus 4 quantity squared. Let's see, that's an 8, so that's a 64. And that's a 2. Square that, so that's a plus 4. So this is the square root of 68. Which, let's see, 2 goes in there 34 times. 2 goes into that 17 times. So am I right saying this would be 2 radical 17? Yeah. Okay. So AC is 2 radical 17. So let's check DE. So that's going to be a big square root. And we'll do 4 minus 0. That stuff might look familiar since we've already figured that out before. 3 minus 2. So this is going to be 4 squared, so that's going to be a 16. That's a 1 squared, so that's going to be a 1. So this is the square root of 17. And that is DE. So if I took exactly 1/2 of this, so if I took 1/2 of AC, that would be radical 17. And does radical 17 equal that? Okay. So we demonstrated, we showed, we verified that the mid segment and the third side of the triangle those are parallel. And we also verified that the mid-segment is exactly half the length, or the opposite of that would be the length of the side is twice as big as the mid-segment. So if you think about it, what did we just demonstrate? What was that called from yesterday? It's not a mystery. Mathematicians try and name things that make sense. What is it?
Mid-segment.
Yeah, it's called the triangle mid-segment theorem. So we just verified that the triangle mid-segment theorem, gosh, it at least works on that one. So we didn't have to prove anything. We could work with numbers the entire time. Okay? So flip the page over. This one's a little more interesting, a little more involved, a little more interesting. It says the medians of a triangle meet at a point called the centroid. We learned that yesterday. Given a triangle with vertices at those, prove the medians meet at a single point. Okay, now, we're not going to prove. I want you to cross out the word. We're going to write the word verify, because we're not really proving anything. To prove something is much more difficult. Okay? We actually have to show that it works no matter what the numbers were, no matter what the triangle was. Okay? So, we're going to do 0, 1 for A right here. I'm going to write A, and I'm going to label it. Again, it's helpful to have the labels on the diagram. B is at 6, 1. C is at 4, 5. So we're way up here. So our triangle looks like this. Okay. So this is stepping us through the process of demonstrating and verifying this is true. It says find the coordinates of D, E, and F, the respective midpoints of AB, AC, and CB. So D is the midpoint of AB. So we're going to put D about right here. That's D. E is the midpoint of AC. So E would be somewhere around right there. And F then respectively would be the midpoint of CB, so that's going to be somewhere around right there, in that ballpark. And that's going to be F. Now, can you look at a couple of those and can you tell what the coordinates are? Yes.
Yeah.
Okay.
Need to verify it.
Yep. Is it helpful that there are grid lines on here?
Yeah.
If there were not grid lines, it wouldn't be so easy. Okay, so we want to verify this. We want to go through and we want to find the midpoints of each one of those. So D is going to be the midpoint between the two of these, A, B. So we're just going to write down the midpoint formula and we're going to add the x's together. So this is going to be 1 plus 1 divided by 2. So I end up with 6 divided by 2, so I get a 3. 2 divided by 2, so I get a 1. Does it look right? Yep. So let's do E. Okay. It looks like we know where it is, but let's double check and make sure. It's going to be the midpoint between the two of these. So adding the x's together, 0 plus 4 divided by 2, and adding the y's together, 1 plus 5 over 2, that's going to give me 2 comma 6. That's going to be 5 divided by 2, so that's going to be a 3. D, will you pull the door shut? Just verifying here. Let's see. Add those together. So 4 plus 6 divided by 2. 5 plus 1 divided by 2. Oops, I need a 1 there. So this is going to be, let's see, that's a 10 divided by 2. So that's going to be a 5. And that's going to be 6 divided by 2. So that's going to be a 3. Okay. How'd we do? Got him?
Yeah.
Okay. All right. Next. Ooh, find the equation of two of the medians. Doesn't matter which ones. So remember, medians, those are not mid-segments. Medians do this. They go from a vertex to the midpoint of the opposite side. So that's a median. Vertex to a midpoint on the opposite side. Vertex to a midpoint on the opposite side. So there are, even with a crappy drawing and not using a ruler, Gosh, it looks like they end up at the same place. So find the equation of two of the medians. I'm going to do this. Okay, I'm going to do AF. I'm going to do that median. So A is 0, 1, and F is, let's write these over here so I've got them. See, this is what I mean. 5, 3. If we've got them next to it, it makes it a lot easier. This one's 2, 3, and the other one's 3, 1. Okay? So F is 5, 3. And the other one I'm going to do is, let's do CD. Let's do this one. So I'm going to draw a little line here, and C is 4, 5, and D is 3, 1. Ooh, equations for the two medians. What do we do? Okay, just a second, just to verify. I got one hand up. Okay, that's a little better. Okay, Lizzie, can you tell us what we need to do first?
I would say find the slope.
Perfect. We're going to find the slope. So the first thing we're going to do is we're going to find the slope here. So the slope on this one is y2 minus y1 over x2 minus x1. So we're going to do 3 minus 0 on the top, 3 minus 1 on the top. Sorry about that. And 5 minus 0. So this is going to be a 2 on the top and a 5 on the bottom. Got the slope. Okay, watch. If you haven't used point slope form very much, it's really nice. So I am going to show you both different ways, but point slope form is very cool because all I need to do is write down y minus y1 equals mx minus x1. And then I pick one of these points and I plug it in. This is x1, y1. So I'm going to do y minus 1 equals, this is going to be 2/5. X minus x1 is 0. So this is y minus 1 equals, this would just be 2/5 x. I move that over by adding 1, so I get this equation. Y equals 2/5 x plus 1. There's one of them. Okay. The other option is to do it like I showed you before. So I'll draw a little line here. Y equals 2/5 x plus b. And then pick one of those and plug it in. This is going to be a 1 over here for the y, 2/5 times x. If you'll notice, that actually is a y-intercept, so we have a huge advantage there. So we end up with 1 equals b. Okay? Either way is fine. Okay, now we'll do this one. So the slope on this one, y2 minus y1, so 1 minus 5, x2 minus x1. So this is going to be 3 minus 4. So this is a negative 4 on the top and a negative 1 on the bottom. So I get a slope of 4. Good? Okay. I'll do this one using slope-intercept form. So I'm going to write down y equals 4x plus b. And then Jack, you want to pick up, should we use C or should we use D for this one?
D.
D, how come?
Because there's a 1.
There's a 1. Smaller numbers, easier to work with. So this is going to be 1 equals 4 times 3 plus b. So that's going to be 1 equals 12 plus b. Move this over to the other side. So we're going to subtract 12. We get b equals negative 11. So here's the equation. Y equals 4x minus 11. Okay, now I'm going to shrink this down just a little bit. And when I got up this morning and was looking this, I put a little bit more space because I realized we probably scrunched this in here. Okay, so take a look at this. We're saying that AC crosses at 1 and has a slope of 2/5. Does that look about right there? For this, AF, for that median. Look okay? We're saying that the median between C and D has a slope of 4 and would cross at negative 11. Does that seem reasonable? Okay, Luke.
Couldn't we have just used the graph and realized that rise over run is 2 over 5, and then we already
the problem is, what if you don't have a graph and we're doing all this verification work? So could you find a shortcut to this? Yes, but we're verifying it. And if you didn't have the grid lines and stuff like that, it would be more difficult. And what if they weren't nice points? Okay. All right, so how do we find the centroid? Mason?
And now we just do our two equations, two unknowns.
Okay, so here's what we've got. I'm going to draw a line right here, and this is what we have. We have an equation that says y equals 2/5 x plus 1, and another equation that says y equals 4x minus 11. And what we want to know is where they cross, right? So we've got a system of equations. What are the methods we have for solving systems of equations?
Substitution and elimination.
Substitution and elimination, and technically graphing. Now, I don't know about you, but with my crappy handwriting and drawing and everything, it looked like they crossed it at the same point, but does it look like a nice point?
No.
It's probably not a nice point. So even if we have a picture of this, even if we have a graph, we're going to end up doing some solving here. So, substitution or elimination, what do you think?
Substitution.
Substitution. Let's just set the two of these equal to each other. So this would be 2/5 x plus 1 equals 4x minus 11. So I'm going to zoom in on this so I've got a little bit more space. I'm going to subtract the 2/5 x. I'm going to add the 11. So this is going to be 12 equals, let's see, that would be 20/5 minus 2/5. So that's going to be 18/5. Flip that over, we're going to multiply by the reciprocal. So this is going to be 5/18. So I get x equals, let's see, 6 goes in here twice, 6 goes in here 3 times. So correct me if I'm wrong, but I got 10/3. Okay? What do I do with that?
Plug it into x.
Yeah, which one do you want to do? First equation or second equation?
Probably
D?
second one.
Second one, we don't have any fractions there. So we're going to do y equals 4 times 10/3 minus 11. So that's going to be 40/3 minus 33/3. So that's going to be how many thirds? 7/3. Y is equal to 7/3. So the coordinates of this point right here ought to be, so right in there, they should intersect at 10/3, comma 7/3. So that's a little bit more than 3 in the x direction, 3 1/3. And let's see, 7/3, so 2 1/3. Does that look about right? Okay, pretty good. Now, at the end of this, and I thought about this morning when I was reviewing this, if you really wanted to be sure that all of those medians intersected at the centroid, what would we want to do? Yeah. Find the third equation, and then we wouldn't have to solve for it. All we'd have to do is check and make sure that that coordinate, 10/3, comma 7/3, actually works when we plug it in. That's all we'd have to do to verify all that. Okay? So, last thing. Okay, I told you we'd give a name to this. This is called coordinate geometry. So when we use XY coordinates to work with familiar shapes and stuff like that, put them on an XY plane, that's a branch of math called coordinate geometry. Okay, let's just use familiar formulas and numbers to verify things. And sometimes the numbers can get really ugly. And would you write this word right here? Tedious. It can get really tedious. It can be a huge pain in the butt. But at the end of the day, you may end up being one of those people who's a scientist, an engineer, an accountant, or somebody like that, who's the one who has to go through and make sure, hey, we've got this idea, or this is the way we're doing things, and verify, is everything working the way we think it should? Okay? And usually those type of people, they make a lot of money. Okay? So that's kind of the thinking skill that we're working on here. Any questions?